This is the Tempter podcast where we discuss embedded Linux, IoT development, and anything else we might find interesting. Your hosts are Kem Raj and Cliff Brake. Today we're going to dive into the details of the Yoe distribution a little bit and kind of talk about some features, how we use them, and how they help us. And the first place to start is Meta Yoe. This is a layer in the Yoe distribution that defines the distribution itself. And Kem, you do most of the maintenance of Meta Yoe, so maybe you could explain kind of what you do there and what you think the important pieces are. And
Yeah, so I think in our last episode we talked about the overall Yoe designs, why we came to Yoe, and so I think this is a good episode. I'm really happy that we covered that, and I'm sure that this episode will be a continuation of more on Yoe distro. So as we know, in Yocto philosophy, or to say open embedded philosophy, we have this concept of layers, and when you have a distribution, you always need a distribution layer. And what does a distribution layer consist of is primarily policies for distribution. And to cite some examples would be what kind of packaging you would want to use for your feeds, where your feeds are hosted. So you might want to encode the URLs, and what kind of init systems you want to use perhaps, and certain package choices or preferred providers, so to speak. So in many cases, there are many competing packages which provide same functionality. For example, package config. So there is a pkg-conf, which is a C implementation, and then there is a good old pkg config. So you can make those choices, which are then going to be distro-wide for you. And then, of course, you will have other settings like whether you want to use, which C library you want to use, or what different output image formats you want to use. So Meta Yoe is basically our distro layer for Yoe distro. What we do in Meta Yoe, in fact, is we define all of these, what we talked about, in a usable form, which basically also gives a profile for us so we can use in different scenarios. So I think we'll go over into more details about how the platform and how the Yoe profile is constructed. And what you will see is we have definitely other portions of package configurations that makes it easy. For example, we want to enable certain features for Yoe distro specifically. That could be that we have certain distro features that are not included in the defaults that you get from core. And these are things, like enabling testing or enabling profiling and other things that are available but are optional. And we also define a very strict QA policy. So we try to use all the packaging QA warnings we get from the build system, and we turn them into warnings into errors. And if you were to build, say, simple OE core based no distro, then those will be reported as warnings. But in Yoe distro, they are treated as errors. So we want to make sure that we have a good check at all those packaging issues that we might encounter. So I think the other portions that are not in there are actually captured into some of our top level configuration metadata, specifically site.conf, and we also provide a sample for local.conf that a user can copy and use as local.conf once they want to add any tweaks on top of what the distro provides.
Mm-hmm. Yeah, the Yoe profile variable is very interesting to me because one thing with Yocto or open embedded to select between glibc or muscle libc, it's a fairly straightforward thing, but it typically involves, searching through the documentation and trying to locate 3 or 4 variables that need to be set.
Mm-hmm. Right. So I think so far what you have seen generally is that, there is one distro, and then you would define, libc and init systems and graphic systems, and then you will live with that. But then the use cases that I was encountering were on kind of different spectrums, and one of them was, working with you on one of the IoT projects where we said, it's a very small edge gateway, doesn't have any graphics, doesn't need to be running, a heavy software stack. Then I think we had normal Raspberry Pi Qt 5 based systems where performance and the resources on the device were not an issue. And most of the time what I was doing was I was using Yoe as my distribution, and then all these settings that I would need to do, selecting various packages or various policies, would go into my local.conf or site.conf or something, and they will be subsumed there. So it started kind of becoming clear to me that it will be much better for us to define these variables and create profiles. Number one, it gives a clear idea to somebody who is trying to build a product, right? So in many cases, they might start with your distro with a open end, and then they will not have that thought out earlier. Should it run X11? Should it run VLAN? Should it run both? Or should it use systemd, or should it not use systemd? We should use sys5 init, or should we? What's our footprint? And it kind of makes you think in those directions early on when you're setting up your project. And that's a good design choice at the very beginning, because I think switching later on is a little expensive, because you have put in efforts in making your system work with the other libc or other graphic system, and then you make this change. It's disruptive, and you might have to undo certain things you have done and pile up more work to support your choice that you're making now. So that was the thought behind it, is that, hey, you could choose a profile and then it will set you up with that profile. And developers in the embedded space, they are fairly clear about some of these requirements if they are presented with a choice, and they often make a good choice at the beginning. And I think that has been the case for me, is that where I know that if I'm making a smaller footprint access point, then we can use BusyBox, we can use Muscle, we can use no graphics, right? So I'll go for that. But then all those profile is a single variable, right? And once you select that, all those choices are made for you, and you can start from a very advanced configuration to add tweaks, obviously, that you might need, but basic system is already set up for you.
Sure. Yeah, it's for those who don't spend a lot of time maintaining Open Embedded, we don't even really know what the options are. So it's kind of nice to have a clear set of options up front where we can kind of see, what are these options, between the libcs and init systems and the graphics, and then, research it and make a good choice up front. And having those as easy available switches is nice. And one other thing I should note is, this is simply using the existing bitbake comp files mechanism to do all this. So there's no magic, there's no scripts running. It's just very simple bitbake configuration include files in the distro conf directory that configure all this. It's a nice level of automation, and also it keeps it simple, which is one of our central philosophies with all this. Is we don't want to add anything magic or hard, but yet we want to kind of set some defaults and make things easier to use.
That's right. Yeah, and I think right now we have and we have basically all the choices for, the combinations of init system and the library, the C library, the graphics or that you want to use, like whether X11 Wayland or just plain XLFS. And I think that basically makes it so in core we have like BusyBox in it, and we have sys5 in it, we have systemd. That's one set, and then we have for libc, glibc, and muscle, that's another set, and then we have X11, and then we have Wayland, and we have XLFS. So that kind of combination makes up, most of the things that you would require. I would say that one more than another, but you definitely have those choices that you can make.
Yeah. So one other thing you've done, Kim, is set up defaults that most people want. And again, if these defaults are set up correctly, it can save a lot of time. You don't have to go digging through the Yocto documentation. Very good, but it's also huge and takes a while to find stuff. But what are some distribution defaults that you think are important, or do you think kind of add some icing on the cake, so to speak?
Yeah. So I think I don't remember. A few days ago, I came across this discussion on IRC where someone, relatively a new user, was looking for, how to set up, for example, he had a Raspberry Pi, and then how could he, basically, he was able to build everything, right, using the image that he wanted to create. It was a base image, which is relatively small, and he had I think a 32 GB card or something like that. And he said that, hey, everything is okay, but it shows 80% disk full, and I have 32 GB card in there. Image is only like less than 200 meg, and how can I make it expand? Or how could I make it 32 GB, right, usable, like a normal install that you'll have on a desktop? So there are several ways to go about it. Like you could create like a 32 GB image, right? And then you can flash it. And then, you could do some other things at runtime, for example. And what we do is we include a package it's from Meta 96 boards, called 96 boards tools. And they have a service called File System Resize. And this service basically runs on first boot and then resizes your rootfs to the size of your SD card, for example. So we add that package to our images. And as a result, what you see is that when you build a Yoe simple image or any other Yoe debug image and you flash it, then once you boot it, then it will automatically expand, for example, your Raspberry Pi SD card to the full size. So it avoids you that pain of figuring it out for yourself, for example. And especially if you're new in this area, this is a big help for you, because most of the time you are not a system developer, right? And you are a developer who is in the application space or in a different part of the system. And these things really kind of come in your way. It is something that is an enabler for you rather than feature. So we thought that that will be a useful thing for an out-of-box experience with the images that are generated with Yoe for the users.
Sure.
So I think another one that comes to mind is how we use BMap tool. So BMap tools essentially, is a bitmapper, speeds up flashing your, images into your cards. And if you were to DD a 16 gig image, it will take you forever. But with BMap tools, it kind of speeds that up by not flashing the zeros into the card. So what you would see is that when you use Yoe install image utility, which is part of our setup scripts, which we talked about in our first episode as well, then it will automatically use BMap tools. And on my desk here, I have a 32 GB card, and when I flash a 16 GB image, it's done in less than 2.5 minutes with a lot of content in there. And I have seen that if you have to flash 32 GB of SD card over USB, It's going to take you quite a bit, depending upon, of course, which class of SD card you have. But I don't have, the high-end one. So this is really, really helpful when, you are doing development. So I think, so these two are kind of like points I wanted to bring here, but this not an only limit. We have even more. For example, we configure systemd. When you choose systemd based profile, for example, then we enable systemd's additional configs, package configs, to ensure that systemd can start networking on your system and name resolution. So one thing, for example, that certain cards or certain boards, rather, they have the MAC address is not static. So what would happen is every time you flash a new image, you'll get a new IP address. And, that's kind of annoying when you have some automation running on it. And, every time you flash a new image, it gets a new IP address. So we handle that in systemd, where we don't want that to consider changing MACs, for example, and, reuse the IP on these kind of boards. So all those are little gems, I would say, that you would figure out, but it takes a while to figure them out. But we basically make sure that they are part of your distro's default configurations for systemd, for example. So yeah, so I think there is a list of them. I think we have some of them documented and more to come.
Yeah, those things really save time, and it's really little tips and things we figure out as we're working with this, and we try to capture that knowledge either in a distribution setting or in a function or a script in env setup, like the BMAP stuff. So yeah, that, and as more users use this, we can learn from them and capture even more ideas that will help people do embedded development more efficiently.
Yeah, you are right. And I think, many of these ideas were picked from discussions, on the mailing lists or, IRC question being asked so many times. There are like documentation out there, and more than often people point them in the right direction. Right? But I think, having it for ourselves is also a very, very useful thing. So that's where Yoe Distro, tries to include all those smarts into default configuration. And I think another thing that I wanted to also talk about is about the images that we create. And for example, we have few standard images, and these are sort of reference images. And you have like Yoe simple image. What that gives you is a basically a very simple bootable image with all the networking and everything. But then we have your debug image, which basically includes not only debugging tools and profiling tools, but also certain utilities like that you might need to inspect, your flash, for example, or other parts of the system. So it's kind of a good image for, probing your hardware. And then we have like Yoe Qt5 images. And you would see that we have Yoe Qt5 Wayland image, we have Yoe Qt5 X11 image, and we have Yoe Qt5 EGLFS image. Underneath, if you don't consider, because it's Qt5 image, so graphics becomes important. So underneath, it's basically all the content being similar. If you have an EGLFS based system, it will be able to run on that one, or the Wayland in similar fashion X11. And we package actually all the Qt5 examples in there, and we make sure that all the dependencies that you require to run those examples are part of the image as well. So what it gives you is that out of box, you can, if you were to do a Qt5 based project, then you can build, one of the profiles you choose, and then the image you will build for that profile, and you are fairly set with all the Qt and Qt5 dependencies, and then you can start working on your application. Before that, if you want to play with some samples and things, all those samples are included into the image. I think that's another smart you will find. And another thing is that if it is Raspberry Pi, it's the same image. If you were to build it for, say, Odroid C2, the same thing. You build the same image, you get same experience. And if you were to build the same image for, say, QEMU x86, hey, go for it. It works there too.
Mm-hmm. Yeah, it's great to have that common experience, and these starting points cover most of the types of applications you might want to build. One thing we've been discussing recently is maybe having like a browser based image, because what's becoming more common is applications written using web technologies and then run in a browser full screen on a LCD. So that's starting to become an alternative to like a Qt5 native app. But we plan to try to come up with some good defaults for that as well.
That's right. Yeah, that's right. I think I'll just expand a little bit on what you said. And so we've kind of like looking into something like a kiosk, which is running on a web technology, perhaps WebKit or maybe Gecko engine, and have a way to have applications then integrate into that. So we would like to create something called maybe a Yoe browser image or something like that.
I guess one other thing we've done with most of the systems we've implemented is a software update mechanism, and we haven't formalized this in the Yoe distribution yet, but we're working on a number of options. The architecture we've typically used in the past is just to have a script can look for update images on a USB disk or a data partition in Flash or even over the network, and reprogram bootloader, the kernel, or the main rootfs, just depending on what's needed. So that's proven to work very well, and it's been very reliable. There's currently in the Yoe distribution, there's an example for the IMX6UL processor. We've also been looking at some other technologies like SW Update and also OS Tree. So those are some things we hope to integrate in the near future and provide some tooling and defaults to use those.
That's right. Yeah, Updater, I think, is one of the key pieces, I think, is OTA nowadays, all the connected devices. And I think it's discussed on and off, but there are many, many choices out there. And, we definitely want to pick a choice for what the needs we have for Yoe distro as well. But we definitely need one. We don't want to leave it out. And because we've been doing Updater in the past, as you mentioned, there's a Yoe Updater already. This is based on, scripts, but it basically has been used very many times. It's very mature, and it works on a single partition systems. And there are various devices where you might not have a mechanism to flash the device directly, for example, and you might have to create production scenarios where the manufacturing would have to flash it from maybe installer like situations where you have your system on the maybe an external storage, something like SD card or USB, and then that transfers the content right into the flash or eMMC, and it's fairly useful in those scenarios we have had in the past. And the IMX6 case you talked about is basically the same case as I described. And I think what we also did is we kind of created this platform abstractions where you could add the information about what different partitions you want to create and what different formats you want to use, whether it should be ext4 or something different. So I think there are other technologies out there. SW Update is there, which does something similar, provides more hoops using Lua to achieve something similar with a little bit of added complexity. And OS Tree is interesting, and I think my take on OS Tree is that it's a good technology for us to implement a OTA mechanism. But I think we've to look into it a little bit more and see how we could deploy it into a usable use case. So definitely, I think the other thing that I really like about is the old update mechanism using feeds. I don't think I like it from the deployment perspective. So what that means is that I wouldn't think that it's a good idea to use those feeds for deployments into your fleet, but it's a good one for development and for rapid prototyping. So so I think, yeah. So what's your take on the data technologies, Cliff?
Yeah, that's an interesting question because we see a lot of options out there. There's Mender and a number of organizations doing embedded Linux have come up with solutions for the update story, and there's SaaS offerings for the cloud part. So there's a lot of good options out there. One thing, I think a single image update, and many people may be surprised at that because they think you need two images to ping pong in between in case one gets corrupted, you can fall back, or so your device doesn't get bricked. But what we found is if you put the kernel with it and an RAMFS and an updater in a boot partition, that will always be there. If the rootfs, you can either have a read-write rootfs, and if it gets corrupted, as long as your kernel will still boot and can read a USB disk, you can recover the system. And for many applications, that's more than sufficient. And the cases where we've actually seen rootfs corruption and devices that won't boot are pretty rare. I can't even hardly think of them. And in cases where we've had updater brick the unit with this single image update, I can't even remember one. So it's been a remarkably reliable mechanism, and I think the reason it's worked so well is it's so simple. It's anytime you have a dual image scenario, it touches every piece of your stack from the bootloader and the kernel, and then the programming. You have to keep track of state as to which partition you're running from, which one to program, which one to boot from.
Yeah.
And when you fall back, you have to manage all that state, and that state needs to be stored somewhere. And, that scenario may be appropriate for some systems, where you may not have access in the extremely rare case where, it won't boot anymore or something. It's a lot of work because it adds a lot of complexity.
Yeah.
And just because somebody has it running on a Raspberry Pi, if you go and bring that to another platform, got to touch U-boot and the kernel and everything. So, yeah, that's something you definitely want to consider. And the simple approach, it may be adequate. It may get you to market a lot faster. So.
Yeah, I think I share sentiments there, and that comes from experience as well. I think we have done both,
Yeah, we've done both. And
so I think we have our learnings as well to share. And I think, it becomes so hard to manage state, as you rightly said, where, it entangles with your data. And one of the things that goes wrong is because you want to do flip-flop because you want to quickly recover if something goes wrong, and the problem there, more often happens is you have databases or some persistent data, and you might have updated a field or something that kind of migrated your data to new format, and so you have to consider those things as well. You should be able to now revert back to your previous format or some way to go back to older snapshot, for example, than OTA. I mean, this perhaps would never be part of your, first line of defense in an OTA, revert strategy. So, yeah, so it sounds very simplistic from the thought that, you tell me I have two options. If one goes wrong, I use the other one. I feel very safe thinking about it, but when it comes down to implementation, the complexities just make it worse, and that has been my learning as well. And I think the other thing that has kind of happened over the past few years is that now your bootloaders have become network aware as well. So in a worst situation, let's say you brick the device or whatever, or by doing an update, your bootloaders, or you could configure your bootloaders to speak to network and get a recovery image or something, and then reinitialize the device that way. So there are techniques nowadays that people can deploy at a bootloader level as well. So in the past, perhaps that was not the case, and they always thought that having what if I go offline, and so there should be an automatic mechanism for the device to switch to the other partition and things like that. So, but yeah, I think there is perhaps, there still are valid use cases in the marketplace today for, flip-flop mechanisms at the added complexity.
Yeah.
So yeah, I think we plan to look into a few others. For example, I'm really interested in OS3 as a update mechanism for a couple of reasons, right? One is it's atomic in nature, and so which means that you can't brick your device so easily. And the Delta updates excites me a little bit because I think transferring full image to the device, is something that costs you network bandwidth as well as you need a mechanism to store it on your device. And in many cases, it may not be possible for you to store because,
Yeah, especially with the cellular connected devices, you just can't afford to do full image updates very often. So
right.
Mm-hmm.
So we will effectively look into these solutions. We already have our updater; it's integrated today. So if somebody checks out Yoe Distro today, they can use our existing Yoe updater and port it to their devices, or it usually will be simple enough, I believe. But I guess more to come. That's what I would put forward here, and see what all we can include, whether we want to kind of use something like SW Update and OS3, both of them made available, or just one of them, perhaps, time will tell.
Yes.
So what do you think about developer story around Yoe Distro? With developer story, I mean not only the Open Embedded developers, but people who are users of Open Embedded want to build a product. So in general, things like feeds and all, so how do we kind of address that need?
Yeah, that's a good question. The developer needs are a little different than the deployment needs. Like you mentioned before, we typically don't deploy package updates in the field. We typically just update an application or the full image.
Mm-hmm.
But for developers, people who want to try different technologies, it seems like the feeds experience more like Debian or Ubuntu, where you can just install anything. Is that kind of what you were thinking about, or?
Yeah.
Yeah. Mm-hmm.
Yes.
And then the other thing that's really nice about Open Embedded is the SDK development or generation, and that has worked out really nice for people who don't want to do full OE builds. That you can build an SDK for them, and then they can build applications outside of OE for development.
Mm-hmm. Yeah. I think to add to that, there was a gaping hole in there in terms of process where the traditional SDK or application SDKs were basically you have to follow a different process to develop the apps. But then if you have to integrate them back into your platform, then that was not it was more or less decoupled process at that point. So either you wrote recipes into Open Embedded, and then that way you integrated back in, or so you provided an image and some manual scripts, things like that, where developer could copy what he built onto the target and run it. But I think recently there has been a new feature basically to address that need, and it's called the Extensible SDK. And I think that's also a good development in the Open Embedded community, which basically is providing you a captured bitbake and other metadata plus the pre-builts, which we call shared state, into a single installer. What that gives you is a good starting point, and it has everything built in. Now, it also has the static tool chain in the traditional speak. So if you had your applications, you can still use it in that sense. So nothing changes for you. But if you were to use the extensible features, then you could basically create image yourself as a application developer. And there is a tool called DevTool. And if you kind of use DevTool, then you can also add a very easy step to add your packages into this modified image, and you can flash the image yourself. So you really don't have to depend on someone to provide you a system image. And then you can have a more custom way of adding your application on top. So I think that's also a good development in the community from developers.
Yeah, we'll definitely have to talk more about that, because I think that will be a very useful forward.
I think so. You have point there. I think we should definitely expand on that one and perhaps talk in detail about the whole, like how the workflow looks like and what different aspects of tooling are. And
Mm-hmm.
so yeah, I think moving forward, I think we have like a very interesting way of interesting take on the reproducibility and managing your builds. So I think we have like container technologies in there that we rely on and we use day-to-day basis. So would you want to talk about like how we do that?
Yeah, that's an interesting story. I had a customer years back that was trying to OJS application into their rootfs, and by the way, I don't recommend deploying Node.js in any shape, form in an embedded Linux image. So we can talk about that some other time. There's better alternatives today, and maybe back then there wasn't. But so it was an old version of Open Embedded that was, they were kind of stuck with for various reasons. It was an obsolete old system on module that needed a certain version of Qt for a certain version of a Linux kernel. Anyway, we're stuck with this ancient version of Open Embedded, and this customer, their build machine, due to IT restrictions, was restricted to a certain OS version, and we needed to build some things that weren't building. Kind of in desperation, I looked around for some ways to change the host environment to another distribution, while still building on their build machine there. And I tried Docker, and it actually worked quite well. And since then, we've provided a Docker container set up with all the host dependencies needed to build Open Embedded. And then this Docker container, we've set up some wrappers around Bitbake so that when you type Bitbake, it actually runs Bitbake inside the container and maps your build directory from your host system into the container, runs the build in the container, and then comes back. So the nice thing is you can do all your editing, with the tools you have set up and everything. And when you run Bitbake, it just transparently does that in the container, and you don't even really know the container's running. And the big advantage of that is these embedded Linux systems sometimes have product life cycles of 5 or 10 years. And Open Embedded typically, if you're using an old version of Open Embedded or Yocto, typically it won't build on say a Linux distribution that's 3 years newer for various reasons. So if you can have a snapshot in time in a Docker container, then you can easily maintain this product with an older version of Open Embedded over 5 or 10 years. So that's been a very, very nice bit of tooling, kind of isolating your host build computer from the actual Open Embedded build process.
Yeah, I think that's a really good point. So essentially, I can relate to it a little bit now. I use Arch for my as a daily driver, and recently Arch updated their file utility to support seccomp, and seccomp doesn't go well with sudo, which is a key technology in Open Embedded for creating the fake root kind of environment. So I started seeing this weird build errors on Arch Linux, and it took me a while to dig it down and find out what's going on. And it seems that the tool is not happy that so sudo basically captures certain syscalls, and that breaks the contract with, I think, with the OS, and it just basically dies down. So end effect is that when somebody is calling the file program on your system, then it segfaults. Now, if I were to build on Arch Linux, and I'm pretty sure that same thing will flow into other distributions sooner or later, because Arch is always at the bleeding edge of the packages. But with your distro, I did not see this issue because, and it occurred to me, it's so seamless that I forgot that it's running in a container environment. I said, I'm building on Arch Linux, both things. It works, it doesn't work. What's going on? So I was trying to build the Yocto reference distro for some reason, and then it took me a bit of understanding this. I see. So I've realized that I've forgotten about, we are building in Docker. So it's quite seamless. And as you said, I still call Bitbake something, and underneath it invokes Docker and does all the builds in the Docker and then comes back to you. So I don't feel like anything that's running on my system. I don't have to like start additional things on my end to enable any specifics for the Docker containers. So
yeah, that's very convenient. And Bitbake and Docker fires up instantly and runs Bitbake almost as fast as if you were running it locally on your computer. Mm-hmm. And the other thing this Docker wrapper enables is it makes it easier for anybody on the team to run a build on their computer, because again, it isolates host dependencies and you don't have to do a lot of support and helping developers, set up their machines or debug weird problems. So it really takes a lot of load off of the system software developers, and reducing their support load if you have a little bit larger team where multiple people are trying to do open embedded development.
Yeah, it's a very good point. I see that there is, a point there where you have different versions of release that you're doing your products on. And in some cases, you're migrating your product from, say, a Yocto 2.2 or 2.3, what have you, to Yocto 3.0. Now, you have your own layers, but your infrastructure is still the same. So it might be that you are using Ubuntu 12.04 and it was working fine for your previous instance of Yocto. Now, Ubuntu 12.04 might no longer be buildable or might be usable for you for these ones, and vice versa. So all these combinations and permutations with your IT infra and the various versions of Yocto in flight makes it a lot more complex. Either you have to have like different VMs or different machines to build different versions of Yocto.
Yeah.
Or so this quickly grows into a matrix that you can't maintain anymore.
Right, exactly. Yeah.
So I think I have seen few issues with Docker release to say, essentially I think those are perhaps not Docker related issues. It's just that I think, there are how like Open Embedded and Bitbake opens file handles and keeps them hot and things like that. So I do see some packaging errors occasionally. My fix has been to clean the package and rebuild it, and that works fine. But it doesn't sound like it's a Docker issue. But yeah, I think it's not a core feature supported by Yocto project, for example. So all the support it doesn't get tested on their auto builders and things like that. So there was a few projects that called Crops, for example, was trying to use Docker underneath. But the project kind of stalled. So, but yeah, so I think those are like little niggles you might see once in a while. But I guess, because I consider myself as power user, and I maybe like not many people will see those kind of use cases which I see, but certainly I think for the benefits that it brings, I think those are really, really small.
Yeah, I agree. There are some hassles. I mean, like one is we haven't figured out how to work with a host user ID other than 1000, which is kind of a pain. But most people, they have a Linux workstation and their user ID 1000, so that's okay. But yeah, you look at kind of the very small issues and compared to the problems it solves, there's no comparison in my mind. And again, it's a very simple Docker container. It's simply a container and a few lines in a bash script to wrap it and wrap Bitbake, and that's it. There's no other tooling involved.
Yep.
So, we feel it provides a lot of value in a very simple way that's not hard to understand, and it solves some real problems.
Yeah. So other issue that I know I kind of saw recently is that I was trying to run p-tests. So, that's another thing we will cover in later episodes. But p-tests don't run under Docker because they need some root permissions and things like that. So the easy workaround for now is that I think we can say, Docker _repo equals none, and off you go.
Yeah. Right.
So it's not that hard to not use Docker as well if you have to not use it. So
yeah, it's completely optional, right?
Yeah. Yeah, so I think that's a very good story for us to move on to some of our documentation initiatives that we have. And I think there's enough documentation out there available in Yocto project, Mega Manual, and so on and so forth. But we have some unique viewpoint on our documentation that we are doing here, and so I think that some of it is basically, I would think that more templatized documentation where you get specific things to do than how it's done from that aspect. So I guess it's more like providing documentation recipes than anything else. What's your take on it? Because I think you've been doing most of it and a commendable job, by the way, so far.
Yeah, I guess I kind of view documentation as notes on how to do things, so that 6 months down the road when I have to do it again, I can quickly figure out how to do it without having to relearn it. Mm-hmm. And really, the env setup.sh script is more just documentation than anything else. The functions mm-hmm. provide some level of automation and convenience, but in the end, they're basically just a collection of commands that you would normally type out. And I really look at them as documentation. We could wrap all this stuff in a Python script or a Go binary or something like that, but then that would just kind of hide what we're mm-hmm. actually doing. So that's why we stick with Bash at the top level, because it's the easiest to understand. Even a make file obscures things quite a bit compared to just a Bash script.
Yeah.
So yeah, and then the documentation itself is more just on how to do things that you routinely need to do during the process of developing a product or using Open Embedded. So that the nitty-gritty details are all in the Yocto documentation, which is very extensive and good, but just quickly finds how to do this. That's the type of documentation we're trying to provide.
Mm-hmm. Yeah, and I think I read through the the libc comparison that you wrote down there. So I think that's very useful for someone like a architect or in that role, who is basically coming up with initial recommendations on what should I do in terms of setting up the basic design. And I think there is good data in there that tells you about various choices if you make. Then mm-hmm. this is the potential savings in size that you might get, for example. And I think that's a very practical documentation right there. And a lot of people look for such data out there on the web. And so more than often there is less context to it, because people have published the data, but there is no code for someone to try it out. In this case, I find it very useful that if somebody goes in there, looks at and says, oh, I see, so this is the difference, checks out Yoe and builds those images and sees it for himself,
Sure.
So I think that's very useful, I think, for a lot of people from ground up. So any more thoughts on what you would like to see in documentation moving forward, or what we would be adding in future?
Yeah, I would like to do more platform documentation, and then documentation on updaters, and I guess just things that we routinely do, and we try to take notes on it, and those turn into documentation. Yeah, we hope to do a lot more of that, and certainly contributions are welcome. Our docs are currently just markdown files in the docs directory in our Git repo, so it's really simple. Mm-hmm. We kind of started with that as the documentation kind of goes with the distribution repo, so that if you have a project that's 5 years old, the documentation is still with that project, versus like a separate documentation mm-hmm. system where the documentation may move forward, but you need a version of documentation that's 5 years back or something. So those are kind of some of the decisions we've made. Again, it keeps it very simple. Anybody can easily contribute documentation because it's just markdown files. So,
mm-hmm. Yeah, I think that's very strong point as well, that documentation is with the code, and I think that's how it has to be. And I like my markup myself as well, markdown as well. Mm-hmm. And I think setting up Hugo was very simple for me, whether it is a Linux desktop or a Mac or anything. So it's fairly simple to kind of add documentation there as well too.
Yeah.
Anything else you would like to cover today?
No, we're probably out of time. So yeah, we appreciate this opportunity. And if anyone has thoughts or topics, we certainly glad for suggestions. And hopefully in the near future, we'll be able to interview some people who have contributed to Open Embedded. And
yeah, I think that's I would be very interested in that, because it will be good to understand the thought process the people who have been with the project from the very beginning had when they started with it. So it all goes to the root, and I think it's very interesting to bring that perspective out and then put it in front of our audience. Looking forward to some of those.
Right. Okay. Well, until next time, take care.
Take care. Thank you.
Yep. Thanks.